Good morning, student. Today I will teach you about gradient, divergence and curl of functions. So our first topic is gradient or slope of a scalar function. If fxyz be a scalar function and this is continuously differentiable, then the vector iota del f upon del x plus j del f upon del y plus k del f upon del z is denoted by del f, and this is called the gradient of function f, and it is written as grade f, which means gradient of f. For example, if fx by z, this is a scalar function because it does not include I, j, k vector, so it is a scalar quantity. So our function f is a scalar function and we have to find grade f or del f at point 1, -1, 1. So first of all, we will find its partial derivative with respect to x. When we differentiate this function with respect to x, we get from first term 4xy³ and second term, because x is not here, so its derivative with respect to x will be 0. Similarly, we can find a del f upon del y and then del f upon del z. Now we know that the gradient of f or del of f is equal to iota del f upon del x plus j del f upon del y and plus k del f upon del z. Now we will put all these values from the previous slide, this one and this one. We get del f is equal to 4xy³, and simplifying this and putting in place of x, y, z 1, -1, 1 respectively, we get from here 1 into 1 is 4. Sorry, 1 into -1, y is -1, so this gives us -4 iota. Similarly, putting x, y, z is equal to 1, -1, 1, we get 12j, and from here we get 9k. So this will be, this is minus, here is -9, so plus 9k. Similarly, we can solve second problem, and in this problem we have given fxyz is equal to xy plus yz plus zx, and we have to find gradient of f at point 1, 1 and 1. So we know that gradient of f is denoted by del f, and its value is equal to iota del f upon del x, j del f upon del y plus k del f upon del z. Now we will put del f upon del x, differentiating this function with respect to x partially, we get x y plus z. So sorry, it is y, this is not x, this is y plus z, then x plus z, then y plus x. Now putting x, y, z is equal to 1, 1, 1, we get 2 iota plus 2j plus 2k. Our second topic is divergence of a vector. So if fxyz is any given continuously differentiable vector function, it is not a scalar function, it is vector function fxyz, then the scalar function defined by del dot f, that means dot product of operator del with function vector function f, is equal to del f1 upon del x, del f2 upon del y plus del f3 upon del z, where f is equal to iota f1, this is plus j f2 plus k f3. So delta dot f is equal to del f1 upon del x plus del f2 upon del y plus del f3 upon del z, and this is called divergence of f, and it is written as divergent f. Similarly, if f is any given continuously differentiable vector function, then the vector function defined by del cross f, and del cross f is equal to iota j k. Del operator coefficients are del upon del x, del upon del y, del upon del z, and f, because f is f1 iota plus f2 j plus f3 k, so its factor are f1, f2, f3. So we will find its cross product, and whatever will be the value of the determinant of this matrix, it will be the curl of f. Now we will find the divergence and curl of f at a point 1 minus 1 1 of function x square z iota minus 2yq z square j plus xy square z k. So because f x y z is a vector quantity, so divergence of f is calculated by del f1 upon del x, where f1 is coefficient of iota, del f upon del x2 upon del y, where f2 is coefficient of j, del f3 upon del z, where f3 is coefficient of k. Now f1, that is coefficient of I, we will partially differentiate this coefficient with respect to x. We will get x square z partial derivative is 2xz. Similarly, we will find the partial derivative of minus 2yq z square with respect to y, and it gives us minus 6y square z square. And similarly from here we get xy square. Now putting the value of xyz is equal to 1, minus 1, 1 respectively, we get minus 3 value. So this is our divergence of f. Now curl of f is calculated by this formula, where it is 3 cross 3 matrix, where first row we put I, j, k, and then the coefficient of del operator, that is del upon del x, del upon del y, del upon del z, then coefficient of function f, that is f1, f2, f3. Now f1, f2, f3 are x square z, then 2yq z square minus, and then plus xy square z. Now we will find its determinant by expanding it along the first row, and we get these values. After putting xyz is equal to 1 minus 1 1, we get the desired result, that is minus 6 iota. Same manner we can find the solid curl and divergence of this function capital F. So by formula, divergence of capital F is equal to del upon del x of coefficient of iota, del upon del y of coefficient of j, and del upon del z of coefficient of. And after finding their partial derivative, we get y square minus 2x square z minus 6xy. Putting xy is equal to z is equal to 1 minus 1 1, we get divergence of f is equal to 9. Similarly, we can find curl of f by this matrix, putting value of and then find its determinant along first row, and we get, after solving these terms, we get the value at point x y z is equal to minus 1 minus 2 iota.